Welcome back to a new video on AI World for You. In this video, let us see about AO star algorithm with an example. In my previous videos, I have explained about the other search algorithms like breadth first search, depth first search and A star algorithm. I have shared the video links in the description. You may go through them. Coming to the AO star algorithm, we can use it for AND/OR graphs unlike the A star algorithm. A star is used only for OR graphs, but here AO star we can use it for AND/OR graphs. And consider this example. Suppose you want a car. You want a car is the goal. So either you can steal it or you can buy with your own money and then get a car, right? So here we have an arc. This arc is nothing but AND condition. So while the tree is being explored by the AI agent, it needs to consider these two as a single path. Although we can see that three branches are here, this AND condition and this arc refers that we need to consider it as a single path. The evaluation function for AO star algorithm is also the same as A star algorithm. We will compute using f of n is equal to g of n plus h of n, where f of n is equal to this g of n is the actual cost and h of n is the heuristic or estimated cost. Now let us see one example of AO star algorithm. Here I have given a tree. So here A has three successors B, C and D, but C and D are having an arc here. That means I need to consider the path C and D together. I cannot calculate the evaluation function for AC separately. I need to do it for A, C and D. Same way here I have E and F which are the successors of B, and I have G, H and I which are the successors of C, and I have J which is the successor of D. So in this tree, how the algorithm will traverse first is, just like A star, first we need to traverse from top to bottom. So for A, the paths are either AB or ACD. So we need to compute the evaluation function f of n for the path AB as well as ACD. When we compute for AB, we will consider the path cost as well as the heuristic value here. So I have 6 as the path cost and I have 5 as the heuristic value. So while applying AO star algorithm here, we need to compute the cost for each and every path just like how we did for A star. But here the difference is that backtracking is there in AO star, and also it won't consider the complete path cost. It will consider only the current path cost. I will tell you what I mean by that. So first, while computing, here the edge costs are not given. So let us assume as 1, and the heuristic values are initially given. Here it is denoted in black color and the striked off value is the initial value actually. So 5 is given for B, 3 is given for C, 4 is given for D, and 10, 11, 3, 0, 0 and I are the heuristic values of the terminal nodes. Now coming to the path A to B. If you consider f of A to B, you need to do 1 plus 5, right? Because the heuristic value is 5. So you will get 6. And when you consider f of A, C, D, you will do 1 plus 1 plus 3 plus 4. Because 2 path costs are there. So 1 plus 1. And heuristic values are 3 and 4. So totally I will get 2, 3 and 4. So I will get 9. Okay. And now out of this 6 and 9, which is the least one? 6 is the least cost one. So my algorithm will begin to explore this path, A to B path. So B has 2 more successors, E and F. Now my algorithm will compute the value of B to E and B to 11. That is F, sorry. So B to E is nothing but the path cost is not given, consider as 1, and the heuristic value is given as 10. So it will be 11. And from B to F also it is 1 plus 11. So it will be 12. In 11 and 12, which is the least cost one? 11. So it is given in green here, this 11. This is the least cost one. Now this value will be sent to the parent node. This is the difference. In A star algorithm, we will be considering the path cost from the initial node till E. That is, if you want to compute for B, you will consider even the path cost A to be 1 and then do 1 plus the heuristic value. But here you won't consider the previous path cost. That is the first difference. And backtracking is not possible with A star, but here we will go backtracking. So after computing the cost till the last level, so here E is the last level, there are no more successors. So after computing, we need to backtrack and go to the parent node. So the value which we calculated, f of n value from B to E, we calculated as 11. So this value will be passed to the parent node B, which is 11 here. So the heuristic cost is now updated to 11. Initially it was 5. 5 was given in the question. We have updated it as 11. Now the same way we need to compute from B to A also. We know that 11 is here and here the edge cost, the path cost is 1. So 11 plus 1 we will get 12. So near A node, start going from the left side through backtracking, we are getting 12. What about ACD? What is the value we got for ACD? We got as 9, right, initially. So now the algorithm will explore this side. Because compared to 12 and 9, 9 is smaller. So the algorithm will begin to explore the ACD path also. Now see the successors of C. C has 3 successors but only 2 paths are possible because here we have an AND path. So C to G we can compute as 1 plus 3, so we are getting 4. From C to HI we can compute as 1 plus 1 plus 0 plus 0, so we are getting 2. Out of 4 and 2, which is the least one? 2. So I have indicated that in green, and now 2 is the least value, so we need to backtrack and take this to the parent node. Initially the heuristic value was 3. Now this 3 gets updated to 2. Okay. And now let us see the D path. Now D has one successor J. So D to J, what will be the function f of n? It will be 1, which is the path cost, plus the heuristic value is also 1. So it will be 1 plus 1, which is 2. Now this 2 will get backtracked and passed on to the parent node D. So 4 is updated as 2. And now we need to see the total cost when we backtrack up to A. So if we choose this path, what will be the cost? We have the 2 path costs from A to C and A to D. We have 1 plus 1. And the heuristic values we got as 2 and 2. So totally 1 plus 1 plus 2 plus 2, we are getting 6. Now this 6 is less than 12. So we can say that this particular algorithm, that is AO star algorithm, will stop the execution here. It will say that this is the optimal path and the cost is 6. The shortest path is A, C, D, G, H, I, J. This is the path it will suggest, and it will say that the cost, optimal cost is 6. Coming to the properties of AO star algorithm, we can say that this algorithm is complete if the branching factor is finite and the costs are positive, because we cannot compute if the costs are infinite or negative, and the graph is finite. Coming to the optimality, we can say that it is not guaranteed because it may stop finding the first valid solution. Coming to the time complexity, it is the same. So order of B power m, and space complexity is order of B into n. The advantages of AO star algorithm is that it is an optimal algorithm and it can traverse according to the ordering of nodes, and it can be used both for OR as well as AND graph. Some of the disadvantages are it cannot be solved when we have unsolvable nodes. It won't be able to find the optimal path, and it is more complex compared to other algorithms. In real life, we can apply AO star algorithm in vehicle routing problems and portfolio optimization. That is, when we want to invest, we can choose the investment which will give us the maximum profit. And also for automatic or self-driving cars, for the routing problems, we can use this AO star algorithm. I hope the concept of AO star algorithm is clear. Thank you for watching this video. If you like it, please hit the like button and subscribe to the channel for more updates. Don't forget to hit the bell icon for regular updates and do share it with your friends. Thank you for watching.